Alright, we'll get started here in just a minute. Gotta just update all the Twitch things. Alright, we'll get started here in just a minute. Hello. So let's see, what are we doing today? Let's just boot it all up. Hello, Karakan. Good morning. It is nearly 7 there on the West Coast. I think I got up just a little while ago, so. Well, the first thing we'll be working on today is we need to get animated physics working properly. Right now, it just kind of FatSack's got the same collision box on every frame, and we need to get that working. And we also need to get turning left and right for our character, making sure that that works with our physics as well. So basically right now, what we've got, like if this is the ground, and we're a character, and our physics box is like right up against a wall, if we turn, if our physics box is not perfectly symmetrical, if we flip about our z-axis, basically what'll happen is our character's physics box may move into the wall when we like turn left or right. And we need to make sure that we handle this case properly. And basically what we were going to do is we're going to set it up so that when we try to change our physics box due to an animation, that we test if we can change our physics box first, and then we do so only if we can. And the same thing has to happen for turning left and right. The same thing needs to happen for if, like, on an animation, you get twice as tall and stuff like that. So it's basically at the beginning of our check of our loop, we need to check if we can change our physics box based on our animation, if it needs to change. And so we need to start adding in stuff like that we can call and make sure it works properly. And we've already discussed a bit of how this can be a little weird. Like if you had a non-symmetrical hitbox with the character and you turned left when you were heading right against the wall, but you or if you're somehow traveling left and you hit the right side of the wall, you could then turn to the right, which might put yourself into the wall, but if you're holding right, you won't actually be able to turn right. So your characters would have the hitbox facing left while looking right, and then maybe if you could jump up over the wall, you might be able to do something odd. So we'll be enforcing a lot of those rules in our art, kind of make sure you have a symmetrical hitbox and things like that. And we're already kind of we're not actually like perfectly up against stuff. We're a little bit outside of it. So we don't have to be absolutely perfect with everything. We have to be very, very close. And when we want to transition to a new animation, we will actually do a couple things like, can I stand up? Will be some of the tests that we'll be running. So we should have a lot of protections against the weird edge cases, but for today, we're probably going to have tons of weird edge cases. So let's see, the first thing we got to do is we got to figure out exactly, let's just boot up and make sure everything's running properly. But we will need to add in, I think, callbacks for when we want to animate our physics box so we can check and then not change if we need to. So we need our paper 2D components to call up into our movement object, and how we're going to do that is by registering a physics change callback, and it's going to have to change itself and then call and then not change itself. So everything's working. So basically what we've got is, when we have this each frame custom collision, we're going to go through all of our physics components and update it. Basically we should always be fine to remove an object from our physics, but we need to, if we make another one or we change it, so it looks like what we've got is we're changing these body setup pointers and the body setups are on the paper physics components. So basically what we want to do is we want to have a callback in here when we change one of these things, and we want to call, and we want this call to go back up to our movement component and have a callback function there. And basically once we call refresh, recreate physics state and all that stuff, we want to check if it worked. And I've got to read all sorts of things to make sure I know what the hell I'm doing. I'm kind of reading about like the body setup and all the rest to make sure I know what I'm doing with it. One of the issues is when we turn left or right, we're changing the transform of our parent object right now. It would flip it, which is what we want to do. But I'm trying to see if there's a transform on our actual physics object that we can mess with. So we can basically check it and then rotate it back or something like that. I mean, the other thing we could do is we could assume that our objects are always completely symmetrical for this on our characters for our movement, and we could enforce that in so many terms as well, which is not a bad plan, to be honest, for the physics boxes. So maybe what we should do is, instead of trying to enforce something that's probably not going to work too well, because there's no transform here that I see on these actual body setups or on the use scene component stuff. Like, I mean, does the U actor component have a transform on it? Actor components have a transform in those scene components. So the scene component does have a transform on it. So supposedly what we can do is add a local transform to this, and what we would do is when we flip our character, we would test if the transform is still proper. And we would then change our transform. Okay, so it's definitely possible. So not impossible, but not the easiest thing in the world either, is what it looks like. Okay, so that looks like kind of our short list. Is we're going to first create a physics check callback and revert system, which will handle per frame collision box changes. We need a turning left and right, and what needs to happen is when our transform is updated, we are going to call and check if we overlap, and if we do, we're going to try to flip ourselves, and if flipping ourselves doesn't get us out of whatever we're in, then we just leave ourselves alone. And we need to make sure that the that the flip transform is called pretty much immediately. Like, we need to basically flip the character and do it. So if we have a frame there where we flip the character but not do anything crazy, so we're gonna need to figure out a good place to actually call this. It's gonna be like a pre-physics update. No, we're gonna have to make it so the only time we ever call left and right is inside of the moving component. And we're gonna have like set direction as like an actual function. And we're never gonna be changing our transform, but anywhere else. That's what it seems like we'll have to do. Alright, so we need to add turning direction to the movement object. Have the movement object call the paper flipbook component. Well, actually, the movement object probably can change the things itself. Alright, so we need a couple things here. We need to go to paperflipbookcomponent.h and create an interface, basically. And the paper flipbook stuff is kind of core. It's not core engine code, but it's as close as we're going to get today. So when we compile it, it's going to take a bit longer to compile and stuff like that. So paper flipbook component, and yeah, we should probably get paper physics component as well. And then we need the CVP files. Alright, so our paper flipbook component is going to call, let's get class. This is going to be like paper flipbook physics callback, and that's just going to be this, and we're going to have a public abstract. Well, it's going to be a virtual bool can change, or it's going to be like is overlapping with world. And when we call this, we're going to call with ourselves. Actually, yeah, we will call with ourselves. This class defines a callback. Paper flipbook stuff. And down inside of our object, we're going to have a protected transient new property, which is going to be a is there such thing as a T set of these? This will just be like callbacks. Yeah, so T set should work. Let's comment it. This set holds the overlap callback objects. And what you're going to do is you're going to call, let's see, register overlap callback, and we're going to pass in an iPaper flipbook callback. And we're also going to have unregister. And we will go implement these methods. So let's look for set collision channel map. Yeah. We're trying to put all of our modifications to Paper Flipbook in our own little area. I think Paper Flipbook has been deprecated by Unreal. I think they had larger aspirations for it, but they kind of ran out of gas. At least that's the latest information that I know, but I really don't know a whole heck of a lot about it. And this is kind of a dirty way to register and unregister callbacks for something. It's just using like some raw pointers, but since we only really need to just like kludge it in there, we're not going to spend 2 million years on it. If this was a much more complicated system where we were doing a whole bunch of crazy shenaniganry, you probably would want some sort of delegate system where you'd be registering yourself and like doing all sorts of other crap, but really I don't care. So I think we're good. So once we have our callbacks in there, I need to look at these, refresh physics, and recreate physics state on our U primitive component. I hate how IntelliSense like makes so you can't do anything. Alright, so refresh physics is going to mark our render dynamic state data dirty and recreate the physics state. So I think it's after we call refresh physics that we can actually, once this returns, I think what we can do is I think we can call our check right here, and if it doesn't actually, if it overlaps after that, then we can do something. So it's going to destroy it, and then it's going to register it. Alright, so this may be an expensive check. Like, we're destroying our physics state, then checking, building a new physics state, and then checking it all over again. But we're not actually destroying all the things. Like, our body setup is still here and all that. So we're not actually recreating everything, I think. We might be. We might be making a horribly inefficient system. But we're trying to kind of play within Unreal's bounds. And if we have to come back and make this more efficient, we can. Alright, later, Kirkan. So this is for every component, for every object in objects. Alright, so we found a matching object code. So we're going to need the previous things here. So we're going to need the previous, all 3 of these things. That's what it looks like. Actually, all 4. And let's see, is it fine to just kludge it together to just be like prev body setup and n32 prev content hash and n32 prev ident code. guess we also need the content hash. We got that. Guess we need the prev ident code, which we have. Body setup. So I guess it's just these three, and we probably also need channel. So we do need the collision channel. This is going to be priv channel, and that's going to equal, what do we got here with like our own physics utils? Let's see, we've got the collision channel, get collision channel for physics code. What are we getting off of that? So I guess we need to get the collision object type. So let me just look it up real quick. Yeah, so let's just get collision object type on this thing. So that'll get all of our previous stuff. So what we're going to do right here is we're going to do a for loop for every one of our callbacks. In our callback stuff, if it returns basically bool now overlapping equals false, we'll just basically just checking like if our callback is overlapping with world, then basically we are now overlapping is true, and we're going to need to revert. So if now overlapping, then basically what we have to do is we have to undo all this stuff. So and we need to pass in all of our previous stuff here. So let's make sure that we're actually setting all these things. So the previous ident code is going to be up here. The object content hash is going to be this. Our body setup is going to be this. So it looks like we also have a thing here where an object can disappear, and that's fine. I don't see any problem with this. So theoretically this should work, and we should be able to go ahead and compile this, and nothing will happen because there are no registered overlap callbacks. So we should be done with this part. So let's just go ahead and build it and see if we screwed anything up. So basically what we're doing today is we got our 2D character at the moment, and he's moving through the world using raycasts. If this is the world, and this is our character, and we're kind of moving through the world with sweeps and raycasts and other things, moving around normals. And right now we are trying to animate our physics. So like if on a couple frames our guy's a little higher or something like that, we're trying to basically, if he animates and then goes into the ceiling, we want to basically just say, no, we're not going to change your physics state. You're not going to have that extra height. And that, we discussed it earlier as a pretty good solution. Must be a U class, U struct, or a U eno. Well, I mean, I guess we can make it a U class, right? Or do we want to just make it a raw thing? I don't think so. I think we need to make it a U class. Let me see. Because we'll be putting in checks basically to be like, okay, can I play this next animation? To be able to check a lot of these. Must inherit from UObject or UObject derived class. Well, let's just double check real quick what we're working with here. And I think we can just do UObject. Yeah, so we can just go ahead and do that. Kind of dirty to throw this in here, but that's what we're gonna do. I wonder if we can just make it virtual or something like that. God, I don't really like it. There's probably a better way to do this. I'm not really sure exactly what a better way would look like though. So this might take a little bit longer since we're compiling paper 2D. Oh yeah, it's got to be a U. Alright, yeah. Got it. Got it. Let's see, is overlapping with world is not defined. Oh yeah, well, it's an abstract class. We'll just have to wait for it to get done being angry. Because we tried killing one of these builds before, and then you have to rebuild the whole damn thing because it's kind of a fragile incremental build process. You gotta wait for it to finish failing before you can try again. Well, so it's getting all pissed off at us. Because it's an abstract class. Well, fine. Let's just say return false. You won't let us make it abstract? Then fine. We won't make it abstract. So yeah, we're just doing coding today, so this stream will probably be going on for quite a while. And we're doing work. We're not trying to be super entertaining. We're not trying to do a bunch of crazy stuff. We're trying to just get some work done on our project. That's pretty much it. So I'm sorry if it's boring, but we're chronicling the work of our project because that's what we do. And it ironically gets more entertaining when we're compiling, because then I'll tell stories about random things. But only when we compile for a long time. Otherwise, it's still incredibly boring. And if you got any questions or anything else, you can always shoot them out there in chat, and I'll do my best to answer them. So, questions about whatever you want. So let's see. We've got that done, so let's get called back inside of our movement object. So the paper flipper component has the uPaperPhysics callback. So instead of being a public U object, we're going to be a public uPhysics thing. And we're going to have to include our paper flipbook component.h right at the top here. So we'll do that. And we're also going to want to implement that method. So is overlapping with world needs to be. We need to actually override this method. I guess we should also be passing in the actual paper physics component pointer that we are testing to see if it has changed. So it should probably look like that. Paper flipbook. And this is a class, so we're gonna you can do a few little forward declaration things, which is what we should definitely be doing. Since they're pointers, I'm pretty sure we can just go ahead and forward declare them and they're not going to get all angry at us. So we need to go update our flipbook component, and it should be calling this, and it should be calling with com. So let's go ahead and go implement this method. Alright, so that's our overlap method. And we're going to need to get our paper flipbook component, which is on our, as far as I remember, it's on our NA actor. So let's go take a look at that. There is get flipbook component. So and we're going to say if our flipbook component is not null pointer, then we need to register ourselves with it. So flipbook what is it called? Register overlap callback. Let me just pass in this pointer. Register ourselves with our flipbook component for callbacks, checks. So I think we should now be getting called back when we get overlap stuff going on. So we may have to include some headers. We already got paper physics, and paper flipbook we had to include at the top of our movingobject.h file because we needed to define it for our class to be able to use it, I'm pretty sure. So we'll take a look here real quick. Oh yeah. Simple things. Simple things. Was Adam still playing Hollow Knight over there in Australia land? Oh man, it's like way past his bedtime. Though if I had lost a whole bunch of work too, that's just always rough. I'm always super paranoid about losing stuff. That's why I've got version control and incremental saves and all sorts of crazy shit with all my work. That's just kind of how you do things. Alright, so we should definitely be getting called back. And the first thing that you do when you write a whole bunch of new crap is you just make sure it runs. How do you lose it? Just not saving, or something crash on him? Did the thunderstorm roll over and destroy his power? Oh, that's funny. So none of these are different ever. Because none of Fat Sack's states are different. Oh man, yeah. Hmm. Well, that means the assets are lost if they're they're already exported, because the source is what matters. You know, you can always recreate what you've imported, but if the source is gone, then you can never fix anything. So let's see, we've got our paper physics components. Where are we creating them? I think there's another place that we need to actually maybe create a paper physics component in. I mean, we need to do our overlap checks. If we're creating a new object here, we're setting our body setup to null pointer, then we're calling refresh physics and register component and all that stuff. Hmm. Oh, I see. So we're setting our body setup to null. If the content hash is the same as the content hash here, I think there's probably a bug in here real quick. It's just like the first time we're going over this. Like our component has it's a null body setup for the body and the hit. Okay. So it is different. Where are we? Which frame? We're in post setup? Okay, so we're actually post setup is where we're calling this thing. And we are setting up our flipbook component first, is what it looks like. So I think this is okay, because when we spawn in our object, it's after this. So we should be fine there. And yeah, I think we're okay with these things. Yeah, we do have our overlap callbacks though here, eventually. And yeah, nothing's different, so we're fine. Okay, so I think we're actually pretty good to go here. The only thing is, Fatsack doesn't have any different animation boxes. All of his boxes are exactly the freaking same, so what we need to do is change that a little bit. We're gonna have to actually go into his art and change him. No, Bitey's all sorts of screwed up right now with his rigging, I'm pretty sure, so I'm not even gonna try it. So I'm just gonna make sure to update and make sure I grab all the files from Adam. Which looks like we're up to date. Yeah, well his file has just got all sorts of crap in it, so he's the most complicated character. It takes time, it takes a lot more time to import him, to export him, to do everything with him, so if I'm gonna be debugging things, I'm gonna be debugging things with somebody a little bit simpler. Alright, so we've got his body physics box here. And we only need a call when it's actually the physics box. We don't need a call when one of the boxes that we don't care about matters. But we'll call back anyway and we'll do like a little check to make sure. Well, he's the go-to guy for me right now. So what we're gonna do is insert a new keyframe here. And we're gonna basically just do something like this, where we take it to 0.3. No, the other way. .5. So if you do it like that, basically his physics box is now should look like. Why is it changing every frame? I don't want it to be every freaking frame. I want it to be like. How do we make these not be? It's like we don't want it to shrink. We want it to just snap at the end of it. Is it a stop motion frame or something? Maybe I should insert 2 keyframes. Is that what this thing wants me to do? what you're doing. Alright, so we should export everything, and we'll see how that works. See, rendering shouldn't take too incredibly long, but of course, it'll take a little while. Well, I figured there's something in there where you can have a keyframe that just changes on the keyframe. Otherwise, if I don't understand what I'm doing, I can always just hack around it, which is what I did there. And let's just go take a look at the FatSack character. So this is just the W idle, probably. Nah, it's the S idle, most likely, right? Yeah, so that's the sprite. So yeah, that's right now. So let's go check on his pivots there, body rect, physics rect, and we changed you on frame 21. Let's see, height and width. The width is now half, so we've got the right data in there. That's what it looks like. So let's boot up Unreal and re-import FatSack. Excuse me. So let's see, it can be kind of time consuming to actually re-import a new character if you do it wrong. So like if we go to FatSack and we just go into like animations, we've got 291 files, and 291 times like 100 milliseconds worth of round trip for perforce for the basic commands can actually equate to like 5 minutes just sitting here. So we're actually going to turn off our source control settings here for a second when we do the import, so it'll be a lot faster. So let's import FatSack. And it looks like they got them. So let's again double check real quick. We can go to FatSack shore collision.